Good day, students. Welcome to our video lesson on understanding variance and standard deviation of discrete distributions. Today, we'll explore these important statistical concepts using a practical example. This is Teacher Eddie, your teacher buddy in statistics and probability. Imagine we're analyzing the number of cars sold per day at a local car dealership. We have data on the number of cars sold and their corresponding probabilities. The number of cars sold, whose random variable represents x, and the probability representing p of x. For 0, we have 1 out of 10. For 1, 1 out of 5 or 2 out of 10. For 2 cars sold, 3 out of 10. 3 cars sold, 2 out of 10 or 1/5. And 4 cars sold, 2 out of 10 or 1/5. Here, x represents the number of cars sold and p of x represents the probability of selling that number of cars. Our main objectives, let's dive into the steps to compute the variance and standard deviation of this discrete distribution. In step 1, we have to calculate the expected value, also known as the mean. This is done by multiplying its value of x by its corresponding probability p of x, and then summing up. The result is equal to 2.20. In our example, the expected value is the average number of cars sold per day. In step 2, calculate the variance, whose variance measures how much the values in the distribution vary from the mean. In this example, we compute it using the formula. Variance of x is equal to the summation of number of cars minus the expected value, or the difference between the number of cars and its expected value squared multiplied to its probability, where e of x is the expected value. Let's take a look. Here, number of cars sold x, 0, multiplied by probability of 1 over 10, that's equal to 0, the product. Since the expected value is 220, we subtract 0 minus 220, that is 0, negative 2.20, and square negative 2.20 becomes 4.84. And after that, this 4.84 multiplied by the probability of 1 over 10 becomes 0.4840. It follows, number 1, the same procedure up to 2, 3, and 4, adding up or adding down, we have 1.82. This 1.82 is the variance, the calculated variance of the number of cars sold. Step 3. Calculate the standard deviation. It's simply the square root of the variance. Standard deviation gives us a measure of the spread of the distribution. Hence, our variance is 1.82. We just get the square root of this variance equals to 1.35. After performing the calculations using our data, here are the results. The expected value, 2.20, the variance is 1.80, and the standard deviation is 1.35. These statistical measures provide valuable insights into the distribution of the number of cars sold per day at the dealership. The expected value gives us the average, while the variance and the standard deviation provide information about the variability or spread around the average. These are the interpretation. For the expected value or the mean, 2.20, this means that on average, the number of cars sold per day at the local car dealership is 2.20. It represents the central tendency of the distribution. In other words, if you were to observe the number of cars sold over a long period, you would expect it to be around 2.20. Variance 1.80. The variance measures the spread or dispersion of the distribution. A variance of 1.80 indicates that the actual number of cars sold per day tends to vary from the mean by an average of 1.80 units squared. This value provides insights into how much the data points deviate from the mean. Standard deviation 1.35. The standard deviation is the square root of the variance and provide a measure of the average distance of data points from the mean. In this case, a standard deviation of 1.35 suggests that on average, the number of cars sold per day deviates from the mean by approximately 1.35 units. It helps quantify the variability or dispersion in the dataset. In summary, understanding variance and standard deviation is crucial in statistics, helping us analyze the spread and variability of data. I hope this video has provided clarity on how to compute these metrics for discrete distribution. Until our next lesson episode, see you.